Let's resume our discussion. In the previous video, we went through all these examples. Now let's go over to the next one. Generalized product rule. If you have three factors, what do you do? And let me see, where is the usual product rule here? It's right over here, and let's copy and paste that thing over here. If you have two functions, u prime v, u v prime, so it's u v u v, but first is a derivative, the second factor is a derivative. Now if you have three factors, u v w, then it's this, u prime v w, u v prime w, u v w prime. So it's the same u v w, u v w, u v w, but the first factor is a derivative, the second factor is a derivative, and the third factor is a derivative, and so on. What if you have four? The same deal. As a matter of fact, what if you have 100 or even more? And theoretically you can do it like this. The first factor is a derivative and everything remains the same. Now the second factor is a derivative, everything remains the same. The third factor is a derivative, everything remains the same, all the way until the last factor is a derivative, like that. How do we apply? Well, let's work this problem out. And let's copy this problem. But let's see, this is power function, so it's a little bit more convenient. We rewrite the problem in power form, and let's work out the derivative. So this is the generalized product rule for three factors, so we need like this. Now the first has to be the derivative function. So what's the derivative of 1? That's 0, and the derivative of exponential remain the same, and that's it. Now this has to become the derivative, so take the derivative. Derivative of x is 1, and take the derivative, power comes out, multiply, and then subtract 1 from the power. This is what we get. Now the third is a derivative, so this becomes 1 over x, and that's going to be it. So this is a derivative function, and then this is a derivative function, and this is a derivative function. What's the answer key? Exactly the same, okay, alright, except for a different choice of color. Similar problem, another problem like this. Well, let's see, do we have enough time? Well, I guess so, so let's do this. 3 square root of x, so let's rewrite it as 1/2 power. 2 over x, so this we can rewrite it x to the negative first power. 3 over square root of x, what's this in power form? 3x to what power? Negative 1/2. And then this one, x to the negative third power, that's the power form conversion. And then let's calculate the derivative. And how do you calculate the derivative here? We're going to be using the generalized product rule. So this one, oops, I clicked the wrong key. Okay, 1, 2, 3, 4, I think that's it. Okay, alright. And then the first factor has to become the derivative, right? So 3x squared plus exponential remain the same. This is the derivative. And then now second has to become the derivative. So 2x and then plus 3/2 x to the negative 1/2 after subtracting 1 from the power, plus 2x to the negative second power. multiplied by -1, we have change there. How about this one now? -3/2, subtracting 1 from the power, and then log of x becomes 1/x. If you prefer power form, you can write it as x to the -1st power. Yeah, I like power form better than the others, so let's leave it like that. And finally, the last factor, and this is plus 15 after multiplicating and then subtracting 1, we get that. This is a derivative. Let's change the color to denote that, and I guess that's a full computation there. Yes, the same computation. I use the traditional notation here, but I use power form here. Power form is better, easier to understand, easier to apply the power rule. Okay, so much for the generalized power rule example. Let's go over to the next set. How about some tangency problems here? Do you have enough time? I guess so. Let's work out the first problem. Y coordinate, we get it by plugging in x0, which is 1. So, alright, plugging x equals to 1, x equals to 1, we get 2e. Oops. Okay. Alright. Now the derivative. It's product of two functions, so product u prime v plus u v prime. That's a derivative, isn't it? Okay, what's the derivative of the first function? What's u prime? Well, it would have been better. This is 1/2 power. 1/2 power comes out and kills off this 2. This is what we get. And how about v prime? Exponential remains the same. So that's the derivative function. The slope, we get it by plugging in x equals to 1. 1 to -1/2 power times e to the first power plus 2 square root of 1 and then e to the first power. What is it? 1/4 of a power is 1, so this is just e plus 2e, which is 3e. So that's the slope. Putting these together, we get the slope point equation of the line. Y equals to 3e x minus 1 plus 2e. That's the slope point equation. Slope is 3e and a point 1, 2e. We got y0 here in step 1, and in step 3 we got m. That's how you do it. Let's see, let's check the answer key here. Okay, the very same, and here's slope intercept equation. Alright, there's no need for duplicate answer keys, so let me remove these. And before moving on, visualization is there. That looks like a constant. Okay, that looks good. Enough time for quotient rule problem? I guess so. Let's do that. What is y naught? From here, all you have to do is plug in x equals to 4. So let's plug in 4. So this is 2 over 2. Okay. This is going to be 1. How about the derivative? Well, this is your function. And then we need denominator squared. and then we need u prime v minus u v prime. There goes the quotient rule. What's the derivative of the numerator here? 1 half x to the negative 1 half power, because square root of x is 1 half power. I need bigger font. And then this should be square root of x. Sorry about the typo. And what's the derivative of denominator? That's just 1, isn't it? Okay, that's the derivative computation. And then let's find out the slope. I'm plugging x equals to 2, x equals to 4, excuse me. I need bigger font. So this is m, and then this is 4 to the negative 1 half power. This is 4 minus 2. That's square root of 4. 4 minus 2, and I don't need times 1. Oh, on second thought, let me keep times 1. And then let's keep on our computation. 4 to the negative 1 half power, what is it? 4 to the 1 half power is 2, that's square root, and then negative, so we need 1 half. So that thing over there is 1 half times 1 half. And then 4 minus 2 is 2. And then square root of 4 is 2. And 4 minus 2 is 2. So we have 2 squared down here. Let's see. 1/4 times 2. So 1 half minus 2 over 4. Looks like I'm getting negative 3 over 8. Okay, please check my mental math. Oh, there's a much easier way to check. Okay, negative 3/8 is correct. Let's write down our final answer. Y equals m x minus x naught plus y naught, and this is the final answer. Well, let's go over to the answer key, which is a little bit more elegantly written. Here we go. Y naught computation, the derivative computation, the slope computation, and finally the slope point equation of the line. How about a visualization? Yes, alright, right here we have tangency.